really quick, I doubt that they'll ask you a question like this, but if they give you a question like this is essentially the same question as before. It's the exact same cubic, but they haven't given you the 3x plus 5 factor. Okay, they haven't given you a starting point. The approach to this question is the exact same, but this time you need to find a factor from scratch. You need to find one of the factors from scratch in order to divide from. Well, how would you do this? Well, the way that I would do this is rather than using the factor theorem and subbing in loads and loads of values using trial and error in my calculator, because that might take you forever, what I would do is I would put this cubic into the calculator, and this would give out the values of, as I said before, 5 minus 5 over 3 and minus 2. And you can figure out the factors from this, but these are also the values in which you sub in for x that will give out 0. Okay, these are the values that would work for the factor theorem, and this makes sense because this is how you find the factors in the first place. So these are the values that work for the factor theorem. So the way I would approach this question is I would find these values, and then I would pick one of them. I'm just going to pick minus 2, and then I would write down this. I would sub in the minus 2, and then you can put it into your calculator if you want, but this will give out the value of 0, and therefore I've proven that this gives out the value of 0, and then I can say therefore x plus 2 is a factor of 3x cubed minus 4x squared minus 45x minus 50. And therefore this is a good way in order to get a starting point, is in order to find a factor you can use a calculator and therefore find what values you can sub in for the factor theorem. Note that I would still write this part down though in order to prove that you understand the factor theorem, as that will help you get one of the marks for the question. But the calculator is useful in this scenario for giving you a starting point into what one of the factors are going to be. So here's a couple of questions on the factor theorem, so pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for question 1, we are given a cubic with 2 unknown terms, and we are given 2 factors of the cubic, 2x plus 3 and x minus 1. Now, due to the factor theorem, therefore we can find that the 2 values that we can sub in for x, 2 of the values that we can sub in for x to give out 0 are going to be, so for 2x plus 3 it's going to be minus 3 over 2, and for x minus 1 it's going to be 1. These are the values that we can sub in for x in order to give out 0. So let's start with minus 3 over 2, so it's going to be 2 minus 3 over 2 cubed plus 9 minus 3 over 2 squared minus 3 over 2 p, as we just sub in minus 3 over 2 here, plus q, and this is equal to 0. So we can simplify this and we can do 2, and then minus 3 over 2 cubed, it's still going to be a minus, and it's going to be 3 times 3 times 3, which is 27. It's going to be 2 times 2 times 2, which is 8 on the bottom, and it's then plus 9 minus 3 over 2 squared, so this is going to be positive 9 over 4 minus 3 over 2p plus q is equal to 0. Then we can expand the brackets, and it's going to be, we can do it for the denominator. We're just going to divide the denominator by 2, as we're timesing it by 2. So it's going to be minus 27 over 4 plus, and then for this 4 and 9, there is 9 can't affect the denominator, so it's going to be 9 times 9 on the top, so it's going to be 81 over 4. You can use a calculator for this if you want, but I would try and do as much mental math as possible for this to save time. Minus 3 over 2 p plus q is equal to 0, and then minus 27 over 4 plus 81 over 4, if you put that into a calculator, it's equal to 27 over 2, and then it's going to be minus 3 over 2p plus q is equal to 0. And then to make the elimination easier, because we're going to have a simultaneous equation, I'm going to move the 27 over 2 onto the other side, so it's going to be minus 3 over 2p plus q is equal to minus 27 over 2, and this is one of the simultaneous equations that we're going to get. Now we're going to sub in 1 as the value of x, so it's going to be 2 1 cubed plus 9 1 squared plus p plus q, as you're just subbing in the value of 1 here, and this is equal to 0 due to the factor theorem. 1 cubed is just 1, so it's going to be 2 plus, and again it's just going to be 9 plus p plus q is equal to 0. This is going to be 11 plus p plus q is equal to 0, and then we're going to move the 11 onto the other side to make elimination easier for the simultaneous equations. So we're going to do p plus q is equal to minus 11, but you could use substitution to find out the simultaneous equations as well. And then what we can do, so we're just going to line these up, so it's p plus q is equal to minus 11 and minus 3 over 2 p plus q is equal to minus 27 over 2. Well, what we can do is because the coefficient of q is the same, we don't actually need to multiply it by anything. We can just minus these from each other like this. So it's going to be p minus 3 over 2p is equal to 5 over 2p. It's going to be q minus q, and these two are just going to cancel out, and it's going to be minus 11 minus 27 over 2, which is going to be minus 11 plus 27 over 2, which, if you put that into a calculator, is equal to 5 over 2. I'm going to write it up here just to make it a bit clearer. 5 over 2p is equal to 5 over 2, and therefore p is just going to be equal to 1. And then we can find the value of q by just subbing it into one of the equations here. I'm just going to use the top one because it looks a bit easier. So it's going to be 1 plus q. We're subbing in 1 for the value of p. 1 plus q is equal to minus 11. So q is equal to minus 12. So the value of p is 1, and the value of q is minus 12. Now you can check these in two ways. First of all, you can check if you've done the simultaneous equations right by subbing it into your calculator using the simultaneous equation feature that's in the same box as the equation slash func. Another way that you can check this is you can sub these in for the cubic, so it's going to become 2x cubed plus 9x squared plus x, or 1x, minus 12, and you can put this into your calculator and you can find the values that it gives out as the solutions, and this is going to be minus 4, 1 and minus 3 over 2, and then you can see what the brackets are going to be from this, and you can see that one of the brackets is going to be x minus 1 due to the 1 here. Remember that it's x is equal to 1, so you bring everyone to the other side, so it's going to be x minus 1 is equal to 0. So one of the factors is x minus 1 of this equation, and the other one is, so minus 3 over 2 is going to give 2x plus 3 as the factor. So therefore we know that this is right because the two factors, when we sub it into the calculator using the two values that we got, we get these two out as factors. So therefore we know that we've got the right equation and we've got the correct values of p and q. I think this technique of subbing it into the calculator is really, really useful again. Okay, so for question 2, part A, we need to prove that x minus 2 is a factor of 5x cubed minus 4x squared minus 11x minus 2. And in order to do that, we just need to sub in the value of 2 into the expression and show that it is equal to 0. This is going to be a 1-mark factor theorem question. So we're going to sub in the value of 2 because it's x minus 2. We're going to do 5 2 cubed minus 4 2 squared minus 11 2 minus 2, and if you put this into the calculator it will give out the value, as you expect, of 0. So therefore, again, this little symbol here, these 3 dots, this just means therefore. You don't even really need to write it if you don't want to, but it's just kind of a shorthand way of saying therefore, the word therefore. So therefore x minus 2 is a factor of 5x cubed minus 4x squared minus 11x minus 2, and we've proved it. Remember, you need to write this little sentence here for factor theorem questions, 1 mark factor theorem questions. Okay, so for part B, so I should have clarified, this is probably like a 5 mark question, so you can't do it using a calculator, otherwise you won't be able to get the method marks. So what this is an algebraic division question where you're going to divide 5x cubed minus 4x squared minus 11x minus 2 by x minus 2 in order to find out what this quadratic is here. So what we're going to do is we're going to do x minus 2 on the outside. On the inside, it's going to be 5x cubed minus 4x squared minus 11x minus 2. Okay, so the first thing that we're going to do is we're going to divide 5x cubed by x, and this is going to be equal to 5x squared, and we're going to write it up here. Then we're going to multiply the 5x squared by the x minus 2, and we're going to write this down here, and this is equal to 5x cubed minus 10x squared. Then we're going to minus these from each other. These two are just going to cancel out, and then it's minus 4x minus 10x, which is going to be minus 4x plus 10x squared, and this is going to be equal to 6x squared, and then we're going to bring the minus 11x down. Then we're going to divide the 6x squared by the x to get plus 6x. I'm going to write it up here. Then we're going to times the 6x by the x minus 2 to get 6x squared minus 12x, and then we're going to minus these from each other. These two are just going to cancel out. Then it's going to be minus 11x minus 12x, which is going to be minus 11x plus 12x. So it's just going to be x down here. I'm going to move the minus 2 down here. Then we're going to divide the x by the x, and obviously that is just going to be plus 1. And then we're going to times the 1 by the x minus 2, and we're going to write this down here, and this is going to be just x minus 2, and then we're going to minus these from each other. These two are just going to cancel out, and there's going to be minus 2 minus minus 2, which is going to be minus 2 plus 2, so this is going to be equal to 0. Now remember, the remainder down here is 0, which is really good to see, because that means that we've done the algebraic division right, because as we know from part A, x minus 2 is a factor of the expression here, the cubic, so therefore we're expecting the remainder to be 0, so that shows that we've done the algebraic expression right, as we've also got a remainder of 0, and therefore we've got the quadratic up here, and therefore we can write it in this form here as x minus 2 5x squared plus 6x plus 1. Okay, so for part C, we need to find the solutions to 5x cubed minus 4x squared minus 11x minus 2 is equal to 0. Well, we found that we can write 5x cubed minus 4x squared minus 11x minus 2 in the partially factorised form here in part B. So we can say that this is equal to 0, and then we can fully factorise this by doing x minus 2 and then factorising this quadratic here, which is going to be equal to 5x plus 1 x plus 1. Hopefully you know how to factorise that, because it's going to be the 1 times 1 is going to give the 1 over here, and then it's going to be the 5x times 1 plus the 1 times x is going to give the 6x here. So that's how it's going to work, and then therefore you can find the solutions by finding when each of these individual brackets is equal to 0. So it's going to be x minus 2 is equal to 0, so x is equal to 2. 5x plus 1 is equal to 0, so 5x is equal to minus 1, and x is equal to minus 1 over 5, and then it's going to be x plus 1 is equal to 0, so x is equal to minus 1. So therefore the solutions and the values of x for when 5x cubed minus 4x squared minus 11x minus 2 is equal to 0 is when x is equal to 2, or x is equal to minus 1 over 5, or x is equal to minus 1. And a very easy way that you can check to see if this is the answer is you can put this cubic into the calculator using the equation slash func box in menu, and then you will find that the values that you get out for the solutions are this 2, -1/5 and -1. So therefore you know that you can check this and you can see that that's the right answer. Although again, don't use that for the actual method, as you're going to need to show some sort of method in order to get the marks, but it's a good way to check that you've got the right answers.